Section 7-4, Part 2. Recognizing nonlinear functions from tables. Identify the tables that represent nonlinear functions and explain your reasoning. So let's look at the table A. So let's determine if we have a constant relationship between the input and the output. So what is your change in your inputs? Well, from 1 to 2, you had to add 1. From 2 to 1, from 2 to 3, you had to add 1. 3 plus 1 gives you 4. 4 plus 1 gives you 5. So we see that the input is constant on A part. All right, let's see if the input is constant on your output, okay? So to go from -8 to -16, all right? What you would want to do here, you see that we're decreasing, okay? If you think on a number line, here's 0, here's -8, well, here's -16. So you see that you're getting smaller. You're going from -8 to -16, you're getting smaller, okay? So anytime that you are getting smaller, you will subtract, okay? So you can always say -8 minus what number is going to give you -16. That's the question. -8 minus what number is going to give you -16? Well, -8 minus 8 is going to give you -16. We could have also looked at it this way. We could have started with the second number, -16, and we could subtracted the -8 that we're given, starting with this number minus that number. Well, -16 minus -8, when you're subtracting, subtraction means add the opposite. So I get -16 plus +8, changing subtraction to addition. The opposite of -8 is +8. So -16 plus 8 gives you -8 also. So either way, we are going to be subtracting 8 to go from -8 to -16. So we had to subtract 8. To go from -16 to -24, you got to subtract 8 again. Okay? So if we say -24 minus 8, we get -32. If we say -32 minus 8, we get -40. So the rate of change, remember your rate of change would be the change of your output over the change of your input. So your rate of change of the output would be -8. Your rate of change of your input is +1. -8 divided by 1 is -8. Your rate of change in this problem is -8. So since your change of your inputs are all the same and your change of your outputs are all the same, then yes, this is a linear function. It is a linear function for Part A. All right, so now let's go to B. Let's determine if this table is also a linear function. So looking at my inputs, you see I am adding 1 each time on your inputs. You had to go 1 plus 1's 2, 2 plus 1's 3, 3 plus 1's 4, and so forth on. So your inputs are all constant. We added 1, okay? I see that I am increasing. You can always subtract the 2, 2.5 minus 1.5. You can always do that on your calculator. You see you're increasing, start with this number, 2.5, okay? So I had to add 1. 1.5 plus 1 is 2.5. 2.5 plus what number is going to give me 5.5? Well, that's going to be 3. Again, you can subtract 5.5 minus 2.5, and you get 3, okay? Here I have 5.5 going to 8.5. I'm having to add 3 again. And then going from 8.5 to 10.5, I need to add 2. Are all of these numbers the same? Is the change of your output constant? No, it is not. So therefore, this is non-linear. B is non-linear. Now let's look at C part. Looking at your input, I'm adding 1 each time. I've got 1, 2, 3, 4, 5. I'm adding 1 each time on the inputs. So let's look at our outputs and see if our rate of change or our change is the same. Increasing, 1 plus 2 is going to give me 3. 3 plus 3 is going to give me 6. 6 plus 4 is going to give me 10. And 10 plus 5 is going to give me 15. Okay? You can always just subtract. 3 minus 1 is 2. 6 minus 3 is 3. 10 minus 6 is 4. 15 minus 10 gives you 5. You see that the output, the change of the outputs are not the same. It is not constant. So this is non-linear. So you had A was a linear function, B was nonlinear, and C is nonlinear.